Next one, we will talk about the battery and voltage source. Every battery got the internal resistance. Because of in the battery, they are electrode. The electrical current need to flow from the positive to negative electrode. So it need to pass through the internal resistance. Therefore, this is the battery symbol here, positive, negative. This battery got the internal resistance. So this internal resistance and the battery voltage. Here is E and F. E, this is internal resistance R. So this is the equivalent circuit for the battery. Battery sub electromotive force is E, internal resistance is R. So this is the terminal. Terminal positive and the negative. Terminal voltage is V. When the electrical current is passing through, the current is also passing through the internal resistance. The voltage drop in the internal resistance. Therefore, we write down the equation. Battery electromotive force voltage E equal to terminal voltage V plus current multiply internal resistance R. So this is the way we can write down the battery equation. So E is electromotive force. E and F of battery. Unit is volt. E is an electromotive force. V is terminal voltage. Terminal voltage is V. I is current. R is internal resistance. So this is for the equation for the battery and equivalent circuit for the battery. Battery got the electromotive force. Battery electrolyte got the internal resistance. So when you connect the battery to supply, there are some voltage drop in the internal resistance. Therefore, we can write down the equation for the battery. Battery voltage E equal to terminal voltage V plus current multiply internal resistance R. So this is the equation for the battery voltage equation. So this is the battery principle. So based on this principle, we will solve this problem. This problem, there are two batteries. Battery 1. Battery 1 got the internal resistance Ri is 0.5 ohm. It got the electromotive force E equal to 1.8 volt. This is a battery 1. And also got another battery 2. This is battery 2. Internal resistance Ri is also the 0.5 ohm. Electromotive force E is equal to 1.8 volt. There are two batteries. Those batteries are connected in series. So this is the batteries are connected in series. So series is a negative connected to this positive. Connected in series and they are connected to supply. So that when you connected to the load, so this is that they are supplying the load. So current I is 150 milliampere. There are two batteries. Battery 1 got the internal resistance Ri 0.5 ohm. Electromotive force E is a 1.8 volt. This is the battery 1. Battery 2, internal resistance 0.5 ohm. Electromotive force is 1.8 volt. Two batteries are connected in series and connected to the load. So the batteries are supplying the 150 milliampere to the load. We had to calculate total E and F. We had to find out the total E and F and voltage in internal resistance. voltage on internal resistance, VRI. And we have to find out the terminal voltage. Terminal voltage is a V. Voltage we have to calculate. So two battery 1 got the electromotive force are 1 by 8 volt, internal resistance is 0.5 ohm. Battery 2, electromotive force are 1 by 8 volt, and internal resistance 0.5 ohm. Two batteries are connected in series and connected to the load. When they are connected to the load, the current is 150 milliampere. We need to calculate total electromotive force. We need to calculate voltage on the internal resistance, and also we need to calculate the terminal voltage. Both things need to be calculated. So firstly, two batteries are connected in series. Battery 1 got the electromotive force are 1 by 8 volt. Battery 2 got the electromotive force 1 by 8 volt. Therefore, total electromotive force is equal to electromotive force 1, electromotive force are 2. So the 1 by 8 plus 1 by 8, you got the 3 by 6 volt. This is for the EMF total. EMF total is 3 by 6 volt. And also we have to calculate the total resistance. So two resistors are connected in series. Therefore, the Ri total equal to Ri1 plus Ri2. Battery 1 internal resistance 0.5 ohm. Battery 2 internal resistance is 0.5 ohm. Two batteries are connected in series. Therefore, we have to add the internal resistance. So Ri1 and Ri2 we have to connect. They are series. So Ri1 is 0.5. Ri2 is 0.5. So you got the 1 ohm. So the current passing through the two resistor. So this is the we calculate VRI equal to I multiply Ri total. Current is 150 milliampere. 150 multiplied with 10 power minus 3. Total resistance 1. So you got 150 multiplied 10 power minus 3 volt or 150 millivolt. This is the way we calculate. Then we need to calculate the terminal voltage. So we write down the equation E equal to V plus IR. E equal to V plus IR. E is an electromotive force, V is a terminal voltage, I is a current, I is an internal resistance. So E we already know is a 3.6. V we don't know. Current I we already know. 150 milliampere. 150 into 10 power minus 3. Total internal resistance is a 1 ohm. Therefore, 3.6 equal to V plus 150 multiplied 10 power minus 3 is 0.15 millivolt. Therefore, we calculate V equal to 3.6 minus 0.15. So therefore, we got 3.45 volt. So this is for the terminal voltage. This way, we can calculate the terminal voltage. This one is the potential divider theorem. Current divider and potential divider. Current divider and potential divider. This means the current divider means they are total current IDF flowing into the two resistor. This is R1, current into resistor R1 is I1, and current into resistor R2 is I2. Total current IT flowing into the two resistor R1 and R2. R1 current is I1, R2 current is I2. In this case, we can calculate the I1. I1 equal to IT multiply R2 by R2 divided by R1 plus R2. And also we can write down the equation I2 equal to I total multiply R1 divided by R1 plus R2. So this is a current divider theorem. Current divider. Total current ID flowing into the two resistors, R1 and R2 are connected in parallel. The current flow to the R1 is I1, the current flow into the R2 is I2. We can calculate I1 equal to ID multiplied R2 divided by R1 plus R2. Also, I2 equal to ID multiplied R1 divided by R1 plus R2. This is the current divider theorem. Then we talk about the potential divider theorem. Potential divider theorem. R1 and R2 are connected in series across the total voltage V. Total supply voltage V, two resistors R1 and R2, they are connected in series and connected across the supply voltage V. So that the current flow into the two resistors, there will be voltage drop. Voltage drop in R1 is a V1, voltage drop in R2 is a V2. So in this case, we can calculate V1 equal to V multiply R1 divided by R1 plus R2. Similarly, V2 equal to V multiply R2 divided by R1 plus R2. So this is a potential divider theorem. Current divider theorem, to the current ID flowing to R1 and R2 parallel. In this case, I1 equal to I total multiply R2 divided by R1 plus R2. Also, I2 equal to I total multiply R1 divided by R1 plus R2. This is for the current divider equation. Potential divider, R1 and R2 are connected in series across the voltage. Terminal voltage is V. So voltage drop in the R1 is a V1, voltage drop in the R2 is a V2. V1 can be calculated, V multiply R1 divided by R1 plus R2. V2 can be calculated, V multiply R2 divided by R1 plus R2. Those are the current and potential divider theorem. Based on those equations, we need to solve this problem. This problem is given. This is the problem. Problem 9. We need to determine the voltage drop. So this is for the circuit here. This is positive. This is the negative side. V total is given the 50 volt. Two resistors. R1 is 300 ohm and R2 is 100 ohm. Then we have to calculate the voltage V. V2 have to calculate. So this is the connection. So this is for the positive and negative terminal. So in this case, two resistors R1 and R2 are connected in series and to the supply voltage 50 volt. So we have to calculate V2. This equation V2 is equal V multiply R2 divided by R1 plus R2. So we substitute total voltage V is 50 volt, R2 is 100, R1 plus R2, R1 300, R2 100. Therefore, 50 multiplied 100 divided by, so this is 400. So this is for the, by solving this one, there will be V2 equal to 12.54. So this is for the potential divider theorem and solution for this problem.